Hello everyone, and welcome to our notes on parallel and perpendicular lines. So today's essential question, as you're recording these notes on paper, is how can you write equations of lines that are parallel or perpendicular to other lines? So the two key terms that we're talking about are what is the definition of parallel, and we're referring to lines that have the same slope, and the definition of perpendicular lines is that lines that intersect and make a right angle, and the slopes are opposite reciprocals of each other. So what we mean by opposite reciprocal is we're going to divide this up into two. When we're referring to opposite, that's being underlined, what we're doing is changing the sign. So if your first number was a positive, we need to switch the sign to a negative. Reciprocal means that we are just flipping the numbers. We're doing the inverse. So here's an example. Say our first number, I wrote down 5 over 2. I need to do the opposite, which is to change the sign. So notice this is a positive. This is now going to be negative. And then the reciprocal is just we're doing the inverse and switching the numbers. So the inverse would be, as I'm writing down, negative 2 over 5. So that is the reciprocal. Another example would be if it was a whole number, say negative 3, which I've written down in this paper. We do negative 3 over 1. So opposite's the sign, so it's positive. And then the reciprocal of 3 would just be 1/3. So let's move on to some examples. So our goal here is to write the equation of a line that passes through the point 6, 8 and is parallel, so the key word there is parallel, to the line of y is equal to negative 5 over 2x plus 10. Then we're graphing both lines. So in our 10 by 10 grid, we're going to find the point 6, 8. We're going to make a point on 6, 8. We're going to go ahead and graph the line y is equal to negative 5 over 2x plus 10. So we're going to find 10, so we're going to circle 10 here. We're going to find 0, 10, and we're going to make a dot there. And then we're going to use the slope, knowing that the change in y, we're going down 5. So we're going to go down here to 5, and then we're going to go to the right 2. And that is where our line is going to be for the first one. And if you want to continue on with this line, you can do that here. Now remember, since we're referring to parallel, as I'm writing down the word parallel, we were referring to the same slope. So I'm writing down same slope. So our slope of the line is negative 5 over 2. So this one has to be 5 over 2. And then it's just doing what we've done before in class when solving in slope-intercept form. You write down your new slope, which is just negative 5 over 2x plus b. You take the point, 6, 8. This is the point that you're going to pass it through. And you're going to substitute that in for x and y. So 8 goes in for y. And 6 goes in for x. So negative 5 times 6 gives you negative 30. Minus 2, divided by 2, gives you negative 15. And the only thing you have left to do is add 15 to both sides, and b is going to be equal to 23. Thus, your equation is y is equal to negative 5 over 2x plus 23. And the significance of this line is that since they are parallel, they will never cross or meet. So that's the significance. So you're using a lot of the same stuff that you've used before in class. Now this next one, for our next example, you're going to write the equation of the line that passes through the point 8, -1, and is perpendicular to the line 4y plus 2x is equal to 12. So we just need you first to write down the 4y plus 2x is equal to 12. What you're going to have to do is you're going to have to rewrite this in slope-intercept form. So you're doing the opposite for standard form. So what you would do is you would actually subtract 2x over to the other side, have 4y is equal to -2x plus 12, and then divide by 4 on all three numbers, because we want y to be completely by itself, and we have -1/2 x plus 3. So then here's our line. So we're going to find 3. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And that's roughly what our line is going to look like over here. Now, perpendicular, so I've underlined the word perpendicular. Remember that is opposite, reciprocal. So if our original slope is -1 over 2, the slope of our new line, remember, is instead of a negative number, it's positive. Instead of it being 1/2, it's going to be 2. And we do the same thing that we've done before. We're going to take y equals 2x plus b. We're going to substitute an 8 and -1. And solve for b. So 8 times 2 is 16 plus b. We're going to subtract 16 over on both sides. B is going to be equal to -17. Our line is going to be y is equal to 2x minus 17. So then we're going to find the point 8, -1, which ironically goes through our green line here. And then we're just going to go over 1 up 2. And you can kind of see where you've made that right angle. So you have to make sure, the super important thing is that you have slopes that are opposite reciprocal when you're talking perpendicular. So make sure you write down all these examples. Have any questions, just let me know.